Hello everyone, welcome you all for the post-contest discussion of Leetcode Weekly Contest. So let's start with the discussion. So this is the first problem. The name of the problem is the two sneaky numbers of Digit Willy. So in the town of Digit Willy, there was a list of numbers called nums containing integers from 0 to n minus 1. Each number was supposed to appear exactly once in a list. However, two mischievous numbers sneaked in an additional time, making the list longer than usual. So, as the town detective, your task is to find those two sneaky numbers, return an array of size 2 containing the two numbers in any order. So peace can return digitally. So the question is that you have been given an array and the array should have contained all the numbers 0 to n minus 1 exactly once, but two mischievous numbers have sneaked in an additional time. So there are two numbers that are occurring two number of times instead of their original time as one. So you need to return those two numbers. So as you see for this particular example, what are the numbers that come two times? You have number 4 coming two times, and you have number 5 coming two times. And order does not matter. Like you can either output 4 comma 5 or 5 comma 4. This completely depends on you. This is actually what the question is, that every number is coming one time. There are only two numbers that are coming two times. You need to return those two numbers. So this can be easily solved via maintaining a map or something called as frequency vector. You can either maintain a frequency vector or a frequency map. So what you can do is, you can just maintain a frequency map. So map will be of type int comma int, where this first value will be the key, that is the number, and the second value, that is the value, will be nothing but the frequency of that particular key or number. So what you can do is, every time you can just initialize your vector int answer. So you can have vector int answer, and every time when you find that the frequency of number has become 2, what does this mean? This means that that number has occurred two times. In that case, simply push that number in your vector int answer and your job is done. This is actually the simple logic to this question. So let's see the code. This is the code. So first of all, I initialized my vector int answer, then constructed a map int comma int mp. So what do this map will do? This map will basically store the frequency of each and every number. Then I simply iterated over all the numbers, increased the frequency of that number, and if the frequency is equal to 2, then in that case, in my answer, I simply pushed back that number. In this way, my answer vector will finally contain those numbers that have the frequency equals to 2. And at the end, I am returning this answer. This is a simple code to this question. So let's move on to the next question. This is the next question. The name of the question is maximum multiplication score. So the question goes as, you are given an integer array A of size 4 and another integer array B of size at least 4. You need to choose 4 indices I0, I1, I2, I3 from the array B such that I0 is lesser than I1 is lesser than I2 is lesser than I3. That is basically you are choosing indices from left to right. And your score will be equal to A of 0 multiplied by BI0, A of 1 multiplied by BI1, A of 2 multiplied by BI2, plus A of 3 multiplied by BI3. So you need to return the maximum score that you can achieve. This is the question. So let's understand the question via the example of via this test case. So the question is that you are given two arrays, array A and array B. Array A is of exactly size 4. So array A is exactly of size 4, as you can see. And array B is of at least size 4. Now what you will do is, you will choose some indexes from some 4 numbers from B. So let's suppose the 4 numbers that I chose is 4, -3, 2, and -7. These are the orders of the numbers in the vector as well. So the first number that you chose from B, that you will multiply with A of 0. That is simply you will multiply it with 3. The second number that you chose, you will multiply with the second number of A, that is 2. The third number that you chose, you will multiply that number with the third number of A. And the fourth number that you chose, you will multiply that number with the fourth number of A. Once you do this, summation of all these values will be your answer. So the question is, as you can see, that vector B, you can choose these 4 numbers according to your choice. Since it contains 7 numbers as of now, so you can choose any 4 numbers. The only thing is that the first number should be multiplied with the first number of A, the second number with the second number of A, the third number with the third number of A, and fourth number with the fourth number of A. And you need to add those all results. So you need to say that what is the maximum answer that you can produce? What is the maximum answer that you can produce? This is actually what the question is. Now, looking up to the constraints of the problem, if you look up to the constraints, then you have the length of B ranging from 4 to 10 power 5. At least it will be 4. That is, you can choose some numbers so that you can multiply the corresponding numbers with this array A. And A of I and B of I ranges from minus 10 power 5 to 10 power 5. Okay. So, you have the length of array B in the order of 10 power 5. So tell me, what is the expected time complexity of this code? What is the time complexity that you are expecting? Something like big O of n, big O of n log n, big O of n square root n. These all will pass the test cases, but something like big O of n square and all will never pass, isn't it? If you have time complexity of big O of n squares or above this, it will not pass. So you need to think of some approach that works within this range, isn't it? Now, you have 4 numbers to choose, isn't it? You have 4 numbers to choose. Let's assume this is array B. What do you actually want? When you are at a particular number, what are the 2 choices that you have? Either you take this number or you not take this number, right? Either you take it or not take it. But in the question, what they have, if you are taking a number, so you also need to know that which number is it? Which number position is this? You also need to know the position of the number. By that, what I mean, if you are choosing this minus 3, so this can be either your second number, first number, your first number, second number, third number, or fourth number. It can be any of the positions, right? And positions do matter, because if this is the third number, if this is the third number that you are selecting, so it will get multiplied with the third number of it. If it is the fourth number that you are choosing, it will get multiplied with the fourth number of it. So are you able to relate that we need an additional constraint that, okay, if I'm not taking it, then no problem. But if I am taking it, so I also need to know that which number is it. I also need to know the position of this number, basically, isn't it? Can we maintain that in our DP? Can we do that? The answer is yes. Why? This is because the maximum number of numbers that you are going to choose is 4, isn't it? So the number that you are choosing is either the 0th number, the first number if I am considering 0-based indexing. So the number that you are choosing is either the 0th index number, the first index number, the second index, or the third index number. These are the only 4 possibilities you have. So in your DP, along with the state of n, like as we usually do while in case of take and not take numbers, you maintain an additional constraint of 4. Once you understand this, now it's a simple transition based that every time you have 2 options. If you are at current IDX, and let's suppose the position or the number that you are going to take, the position of the number is D that you are demanding. So in that case, there are 2 cases. One is I don't take this particular number, so I can just initialize my answer 1 with helper of IDX plus 1, comma G. That is when I don't take this number. If I take this number, so what my answer 1 will become? So if I keep another variable int answer 2, it will become helper of, you will move on to the next number with the next numbered position as well as is also incremented. Plus, since you have taken this number, so what will get added to your result? A of G multiplied by B of IDX. This is something that will get added, that you are choosing this particular number from B and its position was G. If its position was G, so what will get multiplied? A of G will get multiplied to this number and will get added to the result. Now you can simply take max of these two. So you can simply return max of answer 1 comma answer 2 and get your result. Now what will be the base case for this recursion? The base case will be if you reach your G as 4. That is, what does G equals to 4 symbolize? You started with G equals to 0. It changed to 1, then to 2, then to 3, and then to 4. 4 symbolizes that you have already taken 4 numbers, right? You have already taken 4 numbers. This is what 4 symbolizes. So in that case, you can simply return 0. That you don't have, you will not get any more result. So you can simply return 0. Otherwise, if IDX has reached N, that is, you have reached to the end of the array, but G is not yet 4. What does this symbolizes? This symbolizes that you don't have any more numbers to take and you have not chosen 4 numbers as well. In that case, I can return some very lower value because what is my case? I will take max of these two values, right? So in this case, I can return a very minimum value. Let's suppose minus 1e12, something like this, I can return. This will help me to solve this question. This is actually the logic to this question. And what was the basic intuition? The basic intuition was that every time when we come to a number, we have two possibilities. Either we take that number or we don't take that number. If we don't take, then it's all okay. But if we are taking, we also need to know that which position number it is. And for that, we maintain an extra variable. And since that variable was of maximum length 4, so it will not produce TLE. We will discuss time complexity once we discuss the code. So let's move on to the code. So this is actually the code to this question. I have since the answer wants me to return the answer in long, I simply defined LL as long, and I constructed a DP and I took a variable n. So n basically is nothing but the size of this vector B, and DP is nothing but I initialize DP with n cross 4, and all the values are initialized to some very minimum value, that is minus 1e12. Then I passed this helper function with my initial IDX as 0 and my current position, that is the first number that I am going to take, is nothing but of position 0. So I passed it that and two vectors A and B. Now let's see this helper function. Inside this helper function, as discussed, we have two base cases. First of all, if G is equal to 4, we will simply return 0. That is, we have already chosen 4 numbers. Otherwise, if IDX is equals to n, this means that we don't have any more numbers to take in the array and we have not completed our 4 numbers as well. In that case, I am returning some very minimum value. Otherwise, this is a simple DP memoization step, that if DP of IDX of G is not equals to minus 1e12, I am returning DP of IDX of G. Otherwise, I have two possibilities, that I either take this number or I don't take this number. If I don't take this number, so I will simply pass this helper function the next value of index, that is IDX plus 1, and G will remain as it is. If I am taking this number, my IDX will get increased and my G will also get increased. And what will get added to my result? A of G multiplied by B of IDX. Now, one thing was in this question that A and B were of both type int. So if I would have neglected that, if I would have not written that, it will produce an overflow, because two integer values when multiplied and they are two big integer values, I can get an overflow. That's the reason to convert this value to long, I simply multiplied one LL in between. So multiplying one LL makes this entire result as long. Now to this long, when I multiply an integer, the result is long, and it will not produce an overflow. Then we are simply returning our answer and storing the answer in dp of idx of g. So dp of idx, so we are returning dp of idx of g is nothing but max of answer 1 comma answer 2. And this is the complete code to this question. What's the time complexity if I talk of? See, the number of states in a, how do you actually find time complexity in DP? It's basically number of states multiplied by time in transition, right? So number of states is nothing but n cross 4, and the transition time is big O of 1. This is because you are not running any loop and all inside this transition. So transition time is big O of 1. So you can say that, okay, the time complexity of this code is nothing but big O of n cross 4, which can also be written as big O isn't it? So this is actually the code to this question. So let's move on to the third question. Okay. So the name of the question is minimum number of valid strings to form target one. So let's go through the question. You are given an array of string words and a string target. A string X is called valid if X is a prefix of any string in words. You need to return the minimum number of valid strings that can be concatenated to form the target. And if it is not possible to form target, you need to return -1. So a prefix, over here you have the definition of prefix. A prefix of a string is a substring that starts from the beginning of the string and extends to any point within it. So as you can look, you have the words array with you. You have A, B, C, A, B, C, D, E, F, and the target is this. So how can you form the target string? C. First of all, you form the first two letters with the prefix of this particular string. Then next BCD is formed by the prefix of this particular string. Then ABC is formed by the prefix of this particular string. This is how, by using three strings, you were able to completely form this target word. So the answer to this question becomes 3. And you can prove and you can see that there is no lesser than 3 strings via which you can form this target. If you are using the same string twice, you have to count them twice. The example to that is over here that you have two words, this, and the target string is this. Now you can see the first first A of this particular target string is formed by the prefix of this particular string. And the next A is again formed by the prefix of this particular string, A. So since though we have used the same string, but we have used them twice, so my output will be 2. And there can be a case when you can never form the target string from the given prefix of given words. In that case, you have to simply return -1. I hope the question is clear. So let's look up to the constraints. It was a main part in this question. So you have words dot length of the order of 100 and words of I dot length of the order of 5 into 10 power 3. This means that every word in this vector words is of maximum length 100 and the number of words that you have is of the order of 5 into 10 power 3. And sum of words of I dot length is lesser than equals to 10 power 5. That is, if you sum up all these words in this words array, the result will be lesser than equals to 10 power 5. And words of I consist only of lowercase English letters and your target string is of length 5 into 10 power 3. Target consists only of lowercase English letters. So this is actually what the question is. Now let's analyze this question, how we can actually solve this by seeing the constraints. So the target string is of the order of, if I'm not wrong, it's 5 into 10 power 3. Target string is of the order of 5 into 10 power 3, right? So tell me, what type of time complexity would always work over there? Looking up to the constraint, what type of time complexity would always work? Something like big O of n square will always work. Do you all agree? Do you all agree? Big O of n square will always work. You can always use big O of n square. Will big O of n cube work? Will big O of n cube work? The answer is no. So you have to think of something via which you can work with big O of n square time complexity, isn't it? So let's see how we can do this. Let's suppose I tell you this is your target string. Okay. What was the intuition that I got? This is the target string. Now I was thinking that, okay, I have multiple words. Like, let me take it, like, let's suppose ABC, or let me take the example from here only and it will be better. Take this example. That you have, let's suppose your words as A, 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 and BC. These are the two strings that your words contain. And your target string is A. Let me take one additional A. Okay. A, B, C. Okay. This is what your target string is. Now tell me what you will do. You have this target string A, B, C. Now coming to every word, you have two options. Like see, when I come to this A, first of all, I will see, do any words contain this prefix A? The answer is yes. Word 1 also contains, word 2 also contains. Okay. So we will move on to the next word. When we move on to the next word, we will see, do any words contain this prefix AA? Do any word contain this prefix AA? We have, yeah, one word contains this. So we will again move forward. Then we see, do any word contains this prefix AAA? We saw, yeah, a word contains that. So then we move forward. Then we will see, do any word contain this prefix AAAB? Do any word contains that? The answer is no. Then we will say that, okay, from one word, I can take this prefix. From one word, I can take this prefix. And for the next characters in my string target, let's start with a new word. Let's start with a new word. And when you start with a new word, you first of all look, do any word have this prefix B? You will get a clear no. No words have prefix B. No word starts with B. And you will get stuck. You will say that, okay, the answer is -1. But see, the answer is not -1. And where the trick, what is the trick that you missed? What is the trick that you missed? See, when you had these string A, B, C, so you started correct that, okay, do any words have this string A? You told that, okay, we have a word that have prefix as A. So let's move on forward. Then you look for, do any string have this prefix as AA? You got answer yes, yeah, we have this AA. But see, when you look up for this word, when you move on to this particular index, you have a word that have this prefix, but you had two options. When I told you that you have a word that have a prefix AA, you had two options, that either you continue with the same word or you don't continue with the same word. From that particular word, you take this particular prefix, and for the next set of characters, you start with a new word. If you would have followed this part, that is starting with a new word after taking numbers or prefix still here, see, first of all, you will look, do any word have this prefix A? The answer will be yes. There are two words that have this prefix A. Then you will move on to the next word character, that is B, and you will see, do any word have this character string AB as prefix? The answer will again be yes. And you will move on to the next character and you will see, do any word have character ABC as prefix? You again get your answer yes, and you are able to complete the entire string in nothing but 2 words. So instead of getting no as your answer, that is -1 as your answer, you got 2 words. That, okay, there are 2 words. If we combine the prefix of those 2 words by the order in which we want, we will be able to form this target string. So many of you would have got the intuition till now, like what actually the logic is, that every time there are two options. Every time there are two options, that either when you have a word that can be taken with other words and form the prefix, you have two options. Either you take this word in the same prefix, or you tell that, okay, no, from this particular word, I will start a new word. From this particular character, I will start a new word. These are the two options you have. And since you want the minimum answer, you can always take maximum of both these cases and get your result. Once you understand this, now the thing is that how will you actually get that whether this AA is a prefix or not? This AAA is a prefix of some word or not? How you can actually get that? So to get that, there are two options. Like what you can do is, you can maintain a map and you can store all prefixes of strings in word array in your map. But if you do this, if you are doing this, so just try to think, when you have this target length, okay, when you think of that, okay, I am going to see that whether this particular word is present as a prefix in my map, in my any of the words or not. So you will simply find this string in your map. So it will produce, you will find this particular string. Now, when you move on to this next character and you try to find out this particular string in your map, you will get an additional complexity. Again, that if this string is of length n, you are getting log n time complexity. And again, you will get additional log n time complexity once again, and it will definitely produce TLE. So what we can use to find these prefixes in minimum order, like if you know that this prefix is present or not, and if it is present, what data structure you can use so that when you move on to the next character, you are able to choose that, okay, this prefix is present or not in bigger of one time. And this is something that can be done easily via using tries, that is try data structure. So the prerequisite for solving this question is tries. If you are not familiar with tries, I would recommend first of all study tries. I am going to give you a normal, I am going to explain you a bit while explaining the code, but it is a prerequisite. You should understand that what actually tries and how actually tries work and why do we actually use tries, which will definitely help you to solve this question. So let's see the implementation so that the things become more and more clear. So since we had that, okay, at every particular index, we had two options. So for that, what I did is I maintained a DP. I took a variable n. So n is nothing but the target dot size, and DP is initialized to vector int n and initialized to -1, the normal DP as we do. Then I constructed a try. Let's see what I have done in this try. So first of all, for try, I have constructed a try node, that how every node will be seen. So every node will be a pointer to 26 children nodes because we have 26 letters in English alphabet. So every node will contain a pointer to 26 in English alphabet. And initially, all of them will be pointing towards null. Then I have a class try where we have try node star root and the constructor try where the root is initialized to new try node. Then you can see that this is the insertion function in the try. We have the word string which we are trying to insert. So we initialized our node to the root and we are going to each and every character of this string word. First of all, word of I is stored in this child char variable. And if node of children of child minus a is equal to null, this means that initially this particular node did not have that particular child. So in that case, I am just constructing a new try node for that particular child. And then I am shifting my node. This is the basic insertion as we do in tries. So the ones who know tries would very much be familiar with this. Then to solve this question, we have a helper function in which I have my current IDX of my target string. That is in my target string, what is the current index that I am standing in? I have my target string and I have this TP. If my IDX is target.size, I am simply returning 0. This means that I have constructed my entire target string. I don't have any more characters to take. In that case, I am simply returning 0. Otherwise, I am just initializing my node to the root, one thing, and a simple memoization step that if dp of idx is not equal to -1, I am returning dp of idx. Otherwise, I am initializing my answer to some big value, let's suppose 1e6, initialized my current index I to idx, and the size of this target string is stored in variable n. Now, while this I is lesser than n, if you are standing at any current index, if let's suppose this is your target string, if you are standing at any current index, what are the possibilities you have? You will check that whether this is present as a prefix or not, this is present as a prefix or not, this is present as a prefix or not, this is present as a prefix or not. And every time you have two options. Like either you continue with this word or you just don't continue and start with a new word, isn't it? So while this I is lesser than target.size, first of all, in my child variable, I took what the character is present in this target string in this ith index. Then if in my node, if in my current node, this particular child is not present, in that case, I am simply breaking. That is, I can't continue further with this particular word. Like let's suppose I have this B as my target string. And in my try, I only have this A. So I started with A, then I can't move on to the next A because I don't have this A over here. So in this case, I have to simply break, right? So if this is the case, I am simply breaking. Otherwise, I initialized my answer to minimum of, like, see, as I told you, you have two cases. Even if you have that child character, you will tell that, okay, I have made a choice that I will not use this particular character. I have made a choice. So if this is your choice, if that is your choice, so you will just move on to the next index. That is, you will take till particular index I, and you will say that, okay, the current word that I was taking, I will take only till ith index. And from I plus 1th index, I will start with a new word. In that case, you again pass this helper function, this index I plus 1, and you added 1 to your result. Why you are adding this one? This is because you have taken a word, right? You have taken a word, and then for the new word, you have passed this new index. So you passed this new index for starting with a new word. And since you have taken a current word that you were traversing at, so for that, you did a simple plus 1. And if you have decided that, okay, I am not going to take, I am going to not stop over here. I am going to continue my current word. In that case, you simply shift your node and you increment simply your index I. And at the end, you are simply returning your answer. And for the DP, for storing the DP answer, you are just returning DP of IDX equals to answer. So what's actually the time complexity of this code? If you look up, what's actually the time complexity? The time complexity is, first of all, you are inserting in the try. So insertion takes a time complexity of big O of n. If a word is of size n, it takes a time complexity of big O of n. So you are inserting all the words. And if you look up, it's given that the sum of words of I dot length is lesser than equals to 10 power 5. So the insertion time in the try basically takes you big O of 10 power 5. So big O of 1e5, isn't it? And how much this helper function takes time? So this helper function is doing nothing. It has NDP states. And for every state, the transition time, if you look, is of maximum size n. So the time complexity of insertion is nothing but big O of n cross n. And if you look up the value of n, that is the size of the target string, is of the order of 5 into 10 power 3. So n cross n will definitely work in this case. So this is actually the logic to this question, that why we are actually using price. Because if you have one prefix and you want to extend that prefix, so you don't want to search the entire string once again. You want a mechanism via which you can just insert one letter and check whether this prefix is present or not. And that mechanism is possible if you are using price. So I hope this code is clear. So let's move on to our last question. So this is your fourth question. The name of the question is minimum number of valid strings to form target 2. It is basically the extension of the third one. In the extension in the time complexity, the question remains the same, that you have an array of string words and a string target. A string X is called valid if X is a prefix of any string in words. You need to return the minimum number of valid strings that can be concatenated to form target. And if it is not possible to form target, you need to return -1. And the definition of prefix is given over here. So question is exactly the same. The difference is in time complexity. And the time complexity of what? The time complexity of the target string. So target string increases from 5 into 10 power 3 to 5 into 10 power 4. And if you remember, our previous solution was working in big O of n square time. So if we apply big O of n square over here, we will definitely get TLE, right? So we have to think of some better approach. And what is that better approach? So solve this question, we are going to use KMP algorithm. So before talking of KMP algorithm, just let me tell you what our basic idea will be to solve this question. Yeah. So what we are going to do basically, see, if I tell you that, let's suppose your target string is A, A, B, A, C. Okay. And you have two words, A, A, B and B, A, C. These are the two words you. So how will you form this particular string? What you are going to add? You are going to add A, A plus B, A, C. This is something that you're going to do, isn't it? This is something that you're going to do. Now tell me one thing. Tell me one thing. If I just go from back, and I tell you, take the maximum length that you can take. I tell you greedily, take the maximum length that you can take. So what you will do? You will take the CAB and then you will reach over here. And again, I tell you, take the maximum length that you can take. So you will take this AA and you will say that, okay, using two strings, you can form the answer. And this is actually the logic that is going to be. And why will this work? Why will this greedy idea work? This is because, just tell me, if you were able to take AAB from the as a prefix, you can always take AA as a prefix. You can always take A as a prefix. Do you all agree? So when I tell you that take the maximum length from the back that you can take, I tell you this thing. So what does this means? This means that you are actually lowering the number of strings or number of words that you want to take, isn't it? Because you want to take minimum words and form this particular target string. So you are lowering that. And if answer exists, you will get your answer. This is because, as I discussed, that if you were able to take AAB, like earlier, let's suppose you were able to take this AAB and then you were taking some words. And let's suppose this particular word would also been extended up till this. You would have extended this word up till here. So in the earlier case also, like let's suppose you were taking AAB and you were taking CAC and you have three words, let's suppose. The three words were AAB, CAC, and BCAC. Okay. So earlier what you were doing, you were adding this AAB and CAC and you were forming you were using two words and you were forming your string. Now, if I greedily tell you, take the maximum length from the back that you can take. Take the maximum length from the back you can take. What you will do? You see the maximum length from the back that satisfies the prefix condition is BCAC. You will take this particular string. And now from this particular end, you again try to take the maximum length that you can take and you will take this AA. And you will again form your answer by taking two strings AA and BCAC. And why did it work? Because if you were able to take this AAB, then at any time you will be able to take A, you will be able to take AA. Because these are the prefixes of these only, right? So you can anytime take them. And why we are trying to take the maximum length from the back? This is because we want to lower down the possibility of lower down the number of strings, number of words that we are actually using. So to combining these two, we want to lower, we can solve this question greedily. Now the thing is that how to actually get the longest suffix from this string, like the initial string was A, B, C, A, C. This was your target string, right? How to get the longest suffix that matches the prefix of any of the words given. Let me repeat. How can we get the maximum suffix from the target string that matches the prefix from any of these words string adding? If you were, let's suppose this was your initial target string. Once you take this particular word, now your target string, now your index will shift over here. Now you will see that the suffix of this, what is the longest suffix of this, that matches any of the prefix of the target string. And to see this, the longest suffix that matches the prefix, what is the algorithm that we use? KMP algorithm is an algorithm that can be used here to do this thing in big O of one time after pre-computation of big O of n time. So what do we actually do in KMP algorithm? How do we actually find patterns in KLP algorithm? Let me show you an example. So let's suppose you have a string ABC TAB. So what does KMP algorithm does is, if you want to see that where are the things where you are getting this pattern AB, where are you are getting this pattern AB? So what you do is you insert this AB, then a hashtag symbol or any of these symbols such that the things don't overlap. And then you have this target string. And you find the patterns. So at every index in your KMP string, what you get is, you get at particular index, you get the longest prefix that is present as a suffix if your suffix ends at this particular point. Like in this particular example, we are trying to see that we have a word AB. What is the longest prefix of AB at any particular index? So for B, you will get answer as 2. For D, for this particular B, you will get answer as 2. This is because this is one of the suffix that matches the prefix. This is one of the suffix that matches the prefix. So you will get the length as 2 over there. So this is how at any particular index, you can get the maximum prefix length that matches the suffix length. And this pre-computation takes time of big O of n, where n is nothing but the size of the word plus pattern. Once you pre-compute this, once you store this, so what you can do, you have your target string, right? And your current and your initial index is at the back of the target string. So first of all, you will see in all the words, what is the longest suffix that is matching? You will take that word, and now your index will shift over here. Now again, in all the words, you will see the longest suffix that is matching from till this particular index. You will take that word, and again you will shift your index over here. Again, you will see that longest prefix that is matching. If at any point of time, let's suppose you get 0 match, that is, there is not even a single letter that is matching. There is not a single prefix that is matching. What will be your answer then? Your answer will be -1. This is a simple code to this problem. So just a minute. So let's see the code then. The things will become clear. So the prerequisite for this question is that you should know how do you actually calculate this prefix function in KMP algorithm. And the basic intuition is that we can always take the words from the back, and we can always take the maximum suffix that matches any of the prefix in the words. And what is the basic idea? Why this greedy idea is actually working? Because every time we know that whenever we can take a prefix A, we can take A, and we can take A as well. So that's the reason if we are taking the maximum suffix length from the back, we will never get a problem if you were able to form your target string. So first of all, I constructed vector of vector int PIS. So this basically stores for every word, it is going to store that prefix function vector. So what I did is I went over all the words, and in my PIS, I pushed back the prefix function of W, that is the word, plus hashtag plus target. So this is a basic mechanism how you find a target W, the pattern W in this target string. This is a basic pattern of KMP algorithm. Then you initialized your len to target.size and your result to 0 while your len is greater than 0, that you have the target string to form. So you initialized your match to 0. And what you did is you went to each and every word, and you are looking that, okay, at that particular index, like what you will do, you have this word plus hashtag plus this target, and you know that what is the last index of target that you are standing. So inside this prefix function, you will go to this particular index and see the maximum suffix that is matching the prefix, maximum length suffix that is matching the prefix. So what you will do is you will just iterate over this all the words, and your match will be nothing but max of match, comma, PIS of I, words of I dot size plus len. Why we are not doing words of I dot size plus len -1? This is because just remember we also have hashtag included. That's why we are just going over words of I dot size plus len. If our match function is 0 after iterating over all the words, this means that we don't even have a single word that match as the prefix of any of the words, in that case, we are simply returning -1. Otherwise, we are incrementing our result that is initialized to 0. This result basically tells me how many strings I am actually taking, and my length gets decremented by match. At the end, I am simply returning this result, and this is the code to this problem. What's the time complexity if you look? Over here, you are finding the prefix function for each and every word. So you have in total 100 words, right? And you have in total 100 words, and every word takes a time complexity of big O of words plus target string. So over here, you will have something like time complexity if you look up to the constraints. Just a minute. Yeah. If you look up to the constraints, you have words.length as 100. So you have 100 words. And the words of I dot summation length is nothing but 10 power 5. So you will get a time complexity of nothing but 10 power 5, that is 1e5 plus 1e5 plus how many times you will take this target string for word or for the number of times for the number of words you have in this vector. So it will be nothing but 100 multiplied by the length of the target string is 5 into 10 power 4. So 100 multiplied by 5 into 1e. This is the time complexity of this loop, and this loop runs maximum for len amount of time, isn't it? Because every time your len will at least get decremented by 1. If it is not getting decremented, you are returning -1. So it will learn for len number of times, and len is nothing but the size of the target string, which is of the order of 5 into 1e4. And this loop will run for the size of the words array. Size of the words array is maximum 100. So this loop runs for 100. So I can say the total time complexity of this loop will be 5 into 1e4 multiplied by 100. That is equals to 5 into 1e6. So looking up to the constant, we get the total time complexity as 5 into 1e6, which will definitely pass the test cases, and you get the accepted verdict. So I hope you all understood it, how we actually shifted our idea from a brute force tries approach to a greedy KMP algorithm. So I hope all of you got it. Thanks for joining. Thank you.